Good day. So we have a discussion now of Math 3 physics, okay? So to start with, let's read the first question. Two metal blocks of equal mass are heated with the same amount of energy. So I will highlight same amount of energy. Block A increases by 10 degrees. So that 10 degrees is the change in temperature of block A. So 10 degrees. While block B increases by 20 degrees. So the change in the temperature of block B is equal to 20 degrees. Which statement is correct? Okay, so we'll go back to the Gestalt principle of observing the four options. No? Gestalt theory tells that if there are two options that offer contrasting ideas, okay, that will be the site of answer. Okay, so what do you mean by contrasting ideas? Okay, so contrasting ideas refer to a noticeable distinction between subjects. No? So when you say subject of a sentence, okay, it is the primary noun. Okay, so what we're saying here is option A and option C are considered as options with contrasting ideas. There is a noticeable difference between option A and option C. Okay, so option A says block A has lower specific heat. In contrast, block A has higher specific heat. So therefore, you can eliminate B right away, okay? And concentrate now what will be the answer as to if A or C. Okay, now let's have a concept of recall. So the concept here is about how much heat is transferred, no? And that would be knowing the amount of heat, which is called Q. And if you will do the computation, the formula that is required here is Q equals MC delta T. So you could simply read the right side of the equation as MCAT. No? So the M is the mass of the substance, or okay, and then C is the specific heat of the substance. And delta T is the change in the temperature, right, of that particular substance. So delta T is the change in temperature. So we are comparing here the amount of heat transferred by block A with the amount of heat transferred by block B. But the problem statement says that the amount of heat transferred is the same. Okay, so therefore you could say now the Q, okay, of block A is the same as the Q of block B. So the amount of heat transferred by block A is mass times its specific heat times delta T. So we will have it sub A and equal to the amount of heat transferred by block B. So the formula would be MC delta T with reference to block B. Okay, so it is clearly stated that they have equal masses. So therefore, the equation is trimmed down by canceling out the mass. So the left side of the equation simply contains the specific heat of block A times the delta T of block A is equal to the specific heat of block B times the delta T of block B. Okay, now the specific heat of block A is unknown. So the delta T of block A is 10 degrees. Okay, and the specific heat of block B is also not known. So times the delta T of black B, which is 20 degrees, okay? So the Celsius reading will cancel out, and the specific heat of black A is equal to 20 divided by 10 times the specific heat of black B. So the right side of the equation simply tells us double of the specific heat of black B. Okay? So what is indicated here is the specific heat of black A is higher. Okay? So therefore, your answer here would be letter C. Okay? So what did you learn here? Pag mababa yung delta T, mataas yung specific heat. Okay? So we could summarize now the analysis like this. No? If the delta T goes down, the specific heat goes up. If mass and amount of heat are the same. Okay? Pareho yung amount ng mass at saka yung amount of heat. Kaya ang relationship would be based on delta T and specific heat. Okay? So as you increase the specific heat, it is because you lower the change in temperature. So the answer is letter C. So we move to number 2. So just to recap our discussed concept here, the concept is about specific heat capacity. Okay? If both blocks receive the same amount of heat, the block with the smaller temperature increase has the higher specific heat. That's why we chose option C is the correct answer. Okay? So these are the detailed explanation why the other 3 options are wrong. Okay? So letter D is false because the delta T values of the 2 blocks are different. So their specific heat capacities are different also. Okay? So the answer is letter C. Okay? Then we go to number 2. A thermos bottle is effectively mainly because it minimizes. Okay? Now, if you have a thermos bottle, okay, there are 3 types of heat transfer. Okay? And this includes conduction, convection, radiation. Now, a thermos bottle tells us that it is well insulated. So you have a well insulated system, okay? So therefore, a thermos bottle will minimize the 3 modes of heat transfer, okay? So therefore, your answer will be D. Conduction, convection, and radiation are minimized, okay, in a thermos bottle, okay? So A is wrong, okay? If you say thermos bottle reduces conduction, then that is incomplete, okay? Then B is also incomplete because thermos bottle reduces convection, okay? So that is not valid also. Letter C is invalid also, okay? So the correct answer, a thermos bottle minimizes the heat transfer by conduction, convection, and radiation, okay? So let's have number 3, a gas inside a sealed container. So it is a closed container. Okay. So if it is a closed container, okay, the volume will not change. No? And the question is, which quantity definitely increases? So A will not increase. The volume will not increase. It will be constant, okay? Because the container is closed or sealed, okay? So if I would draw a picture of the problem, so there's gas inside, okay? Now, we heat it up, okay? So heating will affect a property of the gas in terms of its kinetic energy. So heating will increase the kinetic energy of the molecules of gases contained in the sealed container. Okay, so our answer here is letter C. Okay, so remember that concept. Heating or increase in temperature will correspondingly increase the kinetic energy of the molecules of gases. Okay, the number of molecules of gases that are present inside the sealed container will still remain constant. Okay, so constant, yeah. So it will never increase. Okay, then the mass density, okay, will not increase also, constant, yeah. Okay, so the answer is letter C. So this would be the basis of our answer as explained, no? Heating a gas increases the average kinetic energy of the molecules, okay? So the concept of recall is what is kinetic theory of gases? And that theory emphasizes that if you increase the temperature of gas, the kinetic energy of the gas molecules will correspondingly increase. Okay. So this is just recalling back what concepts were raised in question number 2. So there are 3 modes of heat transfer. So look at the picture. No? Conduction is in conduction, heat is transferred through direct contact. Okay, so you have a casserole, okay, and it contains hot soup, no? And you have here a spoon. So the spoon is in direct contact with the hot soup. So therefore, you will feel heat is flowing through the handle of the spoon, okay? And the transfer of heat there is conduction because there is a direct heat transfer, okay, between the particles of the hot substance, which is the heat at the hot soup. No? Okay, there will be no transfer or movement of the hot soup to the handle. No? So a metal spoon becomes hot only when placed in a pot of hot soup. Okay, the transfer of heat is by conduction. Now, how would you understand the heat transfer by convection? So if you have convection, heat is transferred by the movement of fluid or liquid or gas, okay? Warm fluid rises, okay? So the molecules that are closer to the heat source would be the molecules at the bottom. So you would see there are red arrows. So the red arrows tell us that the heated molecules are what? Less dense. So it will tend to move upward. Okay. And then the molecules of liquid or gases that are found on the top part of the fluid, okay, are more dense. Okay. So they will go to the bottom. So the continuous flow of fluids from hot to cold, okay, and from cold to hot, okay, is called convection. So warm water rises up, cold water sinks. So that's the principle of convection. Now, how about radiation? Radiation is a mode of heat transfer wherein heat is transferred by electromagnetic waves. Okay, so in the picture you would see a sun. Okay, sun is hot, right? So heat travels through the space as electromagnetic waves. Okay, and the earth becomes hot. Okay, so heat is transferred by electromagnetic waves is termed radiation. So radiation can travel through a vacuum. No medium is needed. Example, as said, okay, heat from the sun reaches the earth through space. So that is radiation. Okay. So number 4, during isothermal expansion of an ideal gas, so I want you to pay attention to the word isothermal. Iso means same temperature. Iso means same temperature. So the prefix iso means the same. Okay. And then there is expansion. So when you say expansion, okay, the gas, when it expands, the volume will increase. Okay, so note that carefully. Okay, now, is a valid statement for the situation wherein there is isothermal expansion? So just to reiterate, isothermal means you keep the temperature constant. So therefore, A saying temperature increases is invalid because the temperature is constant. So you have 3 options left. Okay. What do you think would be the best answer here? Okay. Remember, the gas expands, the volume increases. Okay. So do you think C is the answer? No, because if the volume increases, the pressure, okay, should decrease. But option C says the pressure remains constant. So this is wrong. Okay. So A and C are what? Cross out. And if you remember, in Gesell principle of observing options, you would note that there are always 2 options that are giving us contrasting ideas. Huh? So B and D are what? Contrasting, right? So what do you think would be your answer here? Would the internal energy increase or would the internal energy remains constant? So what would be your answer? Internal energy increase will be false, right? Because during expansion, pressure usually decreases. And okay, expansion, expect that pressure will decrease. But letter C says that, okay, pressure remain constant. Okay, so letter B is also false because internal energy does not increase if the temperature is constant. Okay, so letter B is not valid also. So let me repeat. Since the problem stated that the temperature is constant because of isothermal expansion, the internal energy will never increase. Okay, so that is wrong. So process of elimination, we can say D is the valid answer. Okay, it is correct because the internal energy should remain constant during isothermal expansion. So as a summary, we could write this. In isothermal expansion, volume increases. As the volume increases, the pressure will decrease. And finally, the internal energy will be constant. So the answer is letter B. So remember this useful tip. Huh? Okay. Then we go to number 5. Okay. A car travels east at constant speed. So let me draw the problem. So you have there the car, that is the road. So the direction of the movement is eastward. And it is stated you have constant speed. So if you have constant speed, the car is not accelerating. So acceleration of the car is zero. Okay? So what would be your answer? It's letter B right away, right? Clear? So velocity is zero is wrong because it is stated it has a constant speed. Constant speed does not say velocity is zero, right? So that's wrong. Okay. Okay. What is the reason why A is wrong? Okay. Net force acts eastward. Okay. So option A is wrong because net force eastward would cause acceleration to go eastward. Okay. Go on. So A is wrong. Okay. And momentum is decreasing is also wrong because remember, momentum is one of the fundamental quantities that does not increase or decrease. So momentum is always conserved. So you cannot say momentum is decreasing when a car travels east at a constant speed. Okay? So remember, momentum is calculated using the product of the mass and its velocity. So velocity is present. So you cannot say momentum is decreasing. It's going to be constant because momentum is always conserved. Okay? So D is invalid. Okay. So the basis of our answer is the Newton's first law. Okay. So constant velocity means acceleration is zero. Okay. Then let's have number 6. Two objects are dropped simultaneously from the same height in vacuum. Drop. Okay. So let us have an illustration. Okay. So it was stated that one object is twice as massive as the other. Okay. So you have a small object to mean smaller mass and a bigger object to mean more mass. Okay. They're coming from the same height. So both of these will descend and reach the ground. Okay. So coming from the same height and there is no matter involved, so that means you have vacuum. Huh? Okay. So if the question is which of the two objects will hit the ground first, then your answer is letter C, right? Both will reach the ground at the same time. So B is the answer, C is the answer, okay? So you never answer an option that says cannot be determined. So that is wrong right away, okay? And if you have a lighter object and a heavier object and you let them fall from the same height in vacuum, they will reach the ground at the same time. So C is the answer here. Okay, same time means simultaneously, the two objects will reach the ground simultaneously at the same time. Ang ibig sabihin nun. Okay? And free fall in vacuum. Just remember, in vacuum, all objects fall with the same acceleration regardless of the mass. Okay, so ang acceleration ng lighter object is g and larger object is g. So they have the same value of acceleration. Okay? So number 7, a ball thrown vertically upward slows down because of what? Okay, so let me draw. That's the ball. It's thrown vertically upward. So in terms of its velocity, it's going upward. But remember, this ball, as it rises up, it will reduce its velocity. And in fact, at the topmost part, the velocity of that ball will be equal to 0. Why? Because during the ascent of the ball, the gravity acts on it. Okay? And gravity is always acting up, downward. Palaging pababa ang gravity. So yung velocity paakyat, yung gravity pababa. So what would be the answer to the question? Why is the ball's velocity will slow down as it reaches the top part? Because, okay, look at the syntax of the four options. You would be able to recognize that there are two options that are giving us contrasting idea. So this is offered. Contrasting ideas are seen from option A and B. Okay. So what would be your answer? Gravity acts opposite to the motion of the ball that was thrown vertically upward. So the answer is letter B. Okay. Okay. So this is your set of notes that you could write down so that you will never forget. No? So if you have gravity, okay, that acts on a ball that was propelled upward, the ball will slow down because the gravity acts opposite to the upward motion of that ball. Okay. Then let's have number 8. So let's try to train ourselves on how to observe for the patterns in the four options. Okay. So you would notice that there are two options, no? Okay, that is saying opposite, no? A, behind the passenger. B, it says in front of the passenger. Okay, but letter C is telling us that the ball will land back into the passenger's hand. Okay, and option D, the ball will land outside the bus. The bus. Okay. Now let's read the statement of the problem very well. A passenger inside the bus is moving at a constant velocity. So the bus is moving at constant velocity. And there is a passenger inside the bus. The passenger tosses the ball straight upward. Okay. So the ball was tossed upward. Okay. So it will rise up. Okay. And then it will go down. Okay. And remember the bus is here. Yeah? And the passenger is inside. He tossed the ball. No? Okay. Now, the bus is moving at constant velocity. So therefore, the acceleration of the bus is 0. Okay. So where do you think the ball will land? So it will land back into the passenger's hand. Okay. Letter C is the answer. Okay. Let us explain why. Bakit babalik yung bola sa kamay ng passenger? Okay. So this is about inertia and relative motion. So the ball keeps the same horizontal velocity as the bus. Okay? So yung bus natin gumagalaw patungo dyan. Okay? So yung bola, okay, will also keep the same horizontal velocity. So ang ibig sabihin dito, okay, kung yung bus nagmo-move with a certain velocity, the ball will move horizontally with the same velocity as the bus has. So the ball will land back in the passenger's hand. Okay? So possible questions may come up. Like for example, if the moving vehicle, okay, has a constant velocity, the object returns to the thrower's hand. So that is why the answer is C. Now, if the bus is accelerating forward, the answer to the question, where does the ball land? The ball will land behind the bus. Okay? So behind the bus, okay, would be accelerating forward. So if there is a deceleration, that means the bus driver applied brake. So in that case, the ball will land in front of the passenger. Okay? So letter A is the answer if the bus is accelerating. Letter B is the answer if the bus is decelerating. Nag-apply ng brake yung driver. Kaya yung bola, okay, maglaland in front of the passenger. Okay? Clear? So the key concept is inertia, okay, which is Newton's first law of motion. It is not gravity. Gravity will only change the ball's vertical motion. Okay? Inertia explains the horizontal motion. Diba? Tama? So sabi ni inertia, no, yung bola, okay, meron siyang mass. So yung bus, gumagalaw horizontal. Okay? So kasabay niya, gagalaw din yung bola horizontally. Okay? It will never resist the forward motion. Okay? The ball will never resist the forward motion if you have constant velocity. Okay? So again, A is the answer if the bus accelerates. B is the answer. The ball will land in front of the passenger if the bus is described to decelerate. Okay? So key points. Bus is moving at constant velocity. Acceleration is 0. So the ball will land exactly into the passenger's hand. Okay, so C is the answer. Again, you have isolated system. Ano yung say na isolated in Tagalog? Nakahiwalay. So the question is, which quantity is always conserved? So you could say right away, it is momentum. So the answer is letter C. Okay? Now, kinetic energy can be only conserved in an elastic collision. But in other types of collision, like inelastic, kinetic energy is not conserved. Okay? So A, B, D, you cannot conserve that always. Okay? So the quantity that is always conserved in an isolated system is momentum. Okay? Yeah. So the concept is about conserve momentum. Momentum is always conserved in an isolated system. So, balikan natin yung mga kahulugan ng terms like open system, closed system, isolated system. Okay? So, pag sinabi open system, okay, mass can get in and mass can be moved out. On the other hand, if you have an open system, okay, heat can go in, okay, and work can be transferred, okay? So the red arrow means the heat is going to move out from an open system, okay? So the system outside it is the surroundings. Kung makikita nyo, yung tatlong picture, merong surroundings. Di ba? Okay? Now, what is closed system? In Tagalog, closed sarado. So, dahil sarado yung sistema, walang papasok na mass. So, there's no mass transfer. Pero, pwedeng magkaroon ng energy transfer. So, energy transfer is allowed in a closed system. But a closed system does not allow mass transfer. Okay? Then finally, isolated. Okay? So in isolated system, no mass transfer will take place. Apart from that, no energy transfer will take place. So take note of the X marks. Okay? Okay? So in isolated system, neither mass nor energy crosses the boundary. So that means no interaction with the surroundings if you have isolated system. Okay? Please remember the concept about open system, closed system, isolated system. Okay? Yeah. So if you talk about isolated system, that is the third type of system. So pag sinabing isolated, good examples would be the thermos bottle, the bomb calorimeter, okay, the universe, okay, will receive energy from the sun, okay, and open a universe is considered as an isolated system in thermodynamics. So an ideal insulated rigid tank. So pag sinabing rigid tank, hindi nagbabago yung volume mo. Okay? Tapos insulated, ibig sabihin, no energy transfer will take place. Pero posibleng magkaroon ng what? Mass transfer? Hindi rin posible. So no mass transfer, no energy transfer because we're dealing with isolated system. So pakitanda yan ha, no mass transfer, no heat transfer, no work transfer. Okay? Na magabi na. So in thermos battle, remember, that isolated system in a form of thermos battle will greatly reduce the heat transfer. Okay? So that is why we said that the convection, conduction, radiation, heat transfer are minimized in thermos battle. Okay? Okay? And band calorimeter is very useful procedure for knowing the specific heat of a certain material. Okay? And it is based on the fact that the amount of heat gained is exactly the amount of heat absorbed, evolved. Okay? Heat gain, okay, is equal to heat loss. Okay, number 10. It is clearly stated that you have perfectly elastic collision. It differs from inelastic collision. How? Okay, so what's the difference? So remember, collision, you talk of momentum. So what would be your answer? Momentum is conserved only in elastic. That is wrong because momentum is also conserved in inelastic collision. Okay, so letter A is wrong. Okay, so in perfectly elastic collision, okay, kinetic energy can be conserved, but kinetic energy in inelastic collision, kinetic energy is not conserved. So here, kinetic energy is conserved. Pag elastic, no? But if you have inelastic, kinetic energy is not conserved. Okay, so let us decide now. The difference of elastic collision with respect to inelastic collision is what? So kinetic energy is conserved only in elastic collision. So the answer here is letter B. Okay? Now, letter C, mass changes in inelastic collision. Okay? So letter C is also wrong because mass is conserved. Okay, mass is conserved in elastic or inelastic collision. Diba? So in the real sense, no, kapag yung dalawang kotse nagbungguan, okay, nagbabago ba yung mass nila? Of course not, diba? Okay, so hindi nagbabago yung mass ng dalawang bagay na nag-collide, whether elastic or inelastic. It is conserved. Conserved means the mass will never change. Okay, so C is invalid. Okay. Then finally, letter D, velocity is always zero after collision. Diba? So, velocity depends, okay, on the types of collision. Kaya hindi mo pwedeng gawing na valid to. Always zero afterwards. So, pwede siyang hindi zero. Okay, yung velocity after collision takes place. Okay, D is crossed out. Okay, yan. Kinetic energy is conserved only in perfectly elastic collision. That's why we pull out B as the answer. Okay. So this is option D. Velocity is always conserved. Afterward is wrong. Objects may continue moving after the collision. Tandaan niyo yan. Especially if you are playing with rigid balls in a billiard. Okay. The velocities depend on the type of collision. Okay.